Hey guys, it's Mr. Decker here, and this is lesson 19 of Unit 3, and this one is on collision detection. Our computer science standards for this assignment are creating clearly named variables that represent different data types and perform operations on their values, design and iteratively develop programs that combine control structures, including nested loops and compound conditionals, decomposing problems and subproblems into parts to facilitate the design, implementation, and review of programs, incorporating existing code, media, and libraries into original programs and giving attribution, and systematically testing and refining programs using a range of test cases. Our essential question for this lesson is, how can programming help make complicated problems more simple? Well, that's a very broad question, but think about a microwave, right? Does a microwave work without programming? No, it does not. It has a computer inside of it. Does a refrigerator work without programming? No, it doesn't. It has a computer inside of it. Think about complicated problems in the world and how programming is integrated into our world to make our problems a lot easier to deal with, right? I don't want popcorn tomorrow. I want popcorn now, right? Pop it in the microwave, make it happen. 2.5 minutes later, I'm eating popcorn. All right. This entire lesson is on code.org. Make sure you are signed in on code.org with your school Google account. Your grade for this lesson will be based on your programming in the lesson on code.org. Watching this video is mandatory. Best practice is watching me do a step, pausing, and then completing that step. When you're finished with the lesson on code.org, make sure you are answering the essential question in the text box provided on this assignment page. Please, please, and thank you. All right, I'm already on bubble 1 over here. We've got some vocab and some new code to think about. Our new vocabulary is the word abstraction. An abstraction in programming is a simplified representation of something more complex. Abstractions allow you to hide details to help you manage complexity, focus on relevant concepts, and reason about problems at a higher level. So getting into those higher order thinking skills, right? New code. We've got sprite is touching target and sprite.debug. I wonder what that debug code does. And since we're learning about collision detection, I wonder what that is touching block does. Let's move forward. Bubble 2. On bubble 2, it says dinner time. Run the program to see the robot bring the bunny dinner. When the bunny reaches the bowl, they both stop walking and the bowl becomes empty. What code do you think would help the computer know if two sprites were touching? So we just saw back on bubble 1 that we're going to be learning about the sprite is touching block. So I'm predicting it's probably got something to do with that. All right, run it. Oh, cool. So when the bunny touches the bowl, it gobbles up the food that was in the bowl, apparently. All right, and also they stop moving when the bunny touches the bowl. Interesting. All right, finish. Let's go to bubble 3. All right, excuse me. On bubble 3. Using math to figure it out. Computers use math to figure out whether two things are touching. Look at the math on lines 17 and 18 of this program to see how the sprite properties are compared with their width to see where they are touching. So, okay, we're making a prediction. We're going to look at lines 17 and 18. Is that what it said? Yeah. Look at the math in lines 17 and 18 of this program to see how the sprite properties are compared with their width to see where they are touching. Okay. Wow, look at line 17, look at line 18. So we've got bunny.x is greater than dinner.x, and bunny.x minus dinner.x is less than bunny width divided by 2 plus dinner.width divided by 2. Woof, that's a lot to wrap my head around. And then on line 18, bunny.x is less than dinner.x, and bunny.x minus dinner.x is greater than, there's a minus there, bunny.width divided by 2 plus dinner.width divided by 2. Okay, that's a lot. All right, read the if statements inside the draw loop and find the different sprite properties and how they are compared. So here's the if statement. So if all of this is going on, so check if the bunny and dinner are touching. So all of this code right here is just a lot of complicated math to see whether the bunny and dinner are touching. And if they are touching, stop everything and change to empty bowl. So that stops bunny's velocity, which is set up here, which is what moves it right. And dinner velocities, x changes to 0, stopping its movement. And its velocity was set up here, which makes it go to the left. And the robot's velocity goes to 0, and the robot's velocity was set up here to -3, which makes it go to the left. And then change dinner set animation to bowl. So we're changing the animation up here from stew to bowl. All right. Why does the code only use the width and x properties and not the height and y properties? Okay, we can answer that question. The program does not use height and y properties because the sprites are moving on the, or we'll say, because the sprites, apostrophe, is the sprites x value is changing and their y properties are not. Would you want to write this code every time you checked whether something was touching? Absolutely not. All caps. 3 exclamation points. All right. All right, that's all it wanted us to answer there. So let's run it. And it's the same program we just looked at on Bubble 2, right? So all of this complicated mess is just checking whether the bunny and the bowl are touching. That's a whole lot, y'all. I don't think I like it. I don't like all this code. I want this to be simplified. Please, please simplify it. Like the microwave simplifies my popcorn conundrum, right? Okay, Bubble 4 is touching. Writing out the math each time you want to check whether 2 sprites are touching can take a while, so a programmer created the isTouching block. Thank you, programmer. Thank you, programmer. All right. Thank goodness. Thank you, programmer, for making my life easier. Dear. Okay. All right, so I'm going to start over reading this because that was big. Writing out the math each time you want to check whether 2 sprites are touching can take a while, so a programmer created the isTouching block, which can check whether one sprite is touching another sprite, the target. The computer is still doing the same math as in the previous program, but you don't have to worry about it because another programmer already did that work. Thank you, previous programmer guy, ma'am, sir, lady. Amazing, amazing work. Slow clap. Very much appreciated. Okay. Inside the draw loop, drag the isTouching block to the if block. So let's do some work here. All right, inside the draw loop, drag the isTouching block into the if block. Show me where. All right, isTouching. Oh, we're already in the sprite drawer. Beautiful. Sprite isTouching target, and hint, don't forget to change the sprite to bunny and the target to dinner. Okay, So changing, I'm clicking. Okay, fine. Bunny, oops. If I can type today, we'll be doing great. Okay, Bunny is touching dinner. All right, and then run it, I guess. And so all of that complicated mess from bubble 3, all of this business, all of that messy, gross, disgusting code right there is accomplished with this beautiful, simple code right here. Wonderful. And back over here, answering this question, how can programming help make complicated problems more simple? Oh my goodness gracious. We've answered our own question. Just put it in 2 to 3 sentences. Oh, apparently we're blending apples. All right, making applesauce. The blender should only turn on when the apple touches it. All right. I imagine we're going to do some if touching kind of stuff. All right, do this. Use the new code you have learned to check whether the blender is touching the apple. So control if statement. We're just going to pop them in right here. Sprites. Sprite is touching. And we're going to take this code right here on line 10 that makes the blender shake. Put that down here in line 11 in the then part of our if statement. So if statements are conditionals. A little bit of a review here. The conditional reads out as if sprite is touching target, then blender's x value gets 200 plus -5, 5, which means that basically it's going to be cycling back and forth constantly at a rate of 30 times a second. It's in the draw loop between 195 and 205, which is going to make it go. All right, let's see. So I want if apple is touching blender, then blender's x value becomes. Let's see if we got that to work. Brilliant. All right, there's one more thing though I want to fix. Because see, you can still see the apple going through the blender. I want to fix that and visible. So if the apple is touching the blender, then apple's visibility becomes false. Let's see. Yes. So as far as the computer is concerned, that apple is still falling through that space because it's still obeying this velocity we've set up here on line 4, where that was already set up for us, rather. All right, so the speed of the apple is 4. It blends my apple, making the applesauce. Once the apple is beyond the blender, it's still coming down here because it doesn't change the velocity after it leaves the display area. It still goes at that same rate, moving. So once the apple is no longer touching the blender no longer shakes, right? You're getting it. Finish, continue. Always lots to learn. Debugging collisions. The balloon is popping before the tack touches it. You can use the debug block to get more information about. That's not a question. You can use the debug block. Question mark? Question? Should this be can you? The balloon is popping before the tack touches it. Can you use the debug block to get more information about the bug in the program? I don't know. Can we? Let's see. Do this. Run the code and use the arrow keys to move the tack to pop the balloon. Run. Oh, that's... Hey. It popped before I ever got to it. Let's move it down. And then over. Oh, still pops before I get to it. Okay. In the code below, change balloon.debug equals false to balloon.debug equals true. So here on line 3 is balloon.debug equals false. So I want to change that to true. Add a new debug block. Okay, sprite.debug. And set the tax sprites debug property to true. So tac true. Run the code again, then discuss with your partner why the balloon is popping early. Run. Ah, now I can see the hitboxes. Now, okay. And so even though I went down here, right, I'm still hitting, see the green lines? You see the green lines? All right. Oop. And then its hitbox gets way smaller when it becomes the pop. So I want to fix that. How do I fix that? That's a problem. It's a big problem, y'all. All right, so apparently the debug block, if I change it to true, I can test my program or test my collisions or test my hitboxes to make sure they're the right size or shape, potentially. Moving forward, bubble 7. All right, collision practice. Practice using the collision detection with these activities. A debug is touching. Figure out why this code is not detecting the collision even though it calls is touching. Okay. The bunny sprite should change to a new animation when it touches the sun sprite. Figure out why the bunny doesn't react to the collision. Run. Oh, he's so sad. Why are you so sad, bunny? Let's go to the animation tab. Oh, he's going to get happy. I like the happy bunny. Sad bunny. Little emo bunny. All right. Emo bunny has been listening to entirely too much emo rap or emo rock. The sun is angrily bearing down on him, though. Look at that. And that's going to make him happy? Okay. Modified the code so that the collision is detected within the draw loop. So control if. Actually, I'm going to set the velocity out here because it should run the same way. Yes. If sprite is touching target, if sun is touching bunny, then what does it want me to do? The bunny sprite should change to a new animation. So, oh, it's already set up there. I see the problem. So velocity shouldn't be in there. The if statement should be. I'm going to version history this. Start over. Okay, wonderful. All right, so all the code was here. I just wasn't seeing it. This if statement needs to be in here so that the computer is constantly checking that if statement. The velocity needs to be set up here, not in here. So if sun is touching bunny, bunny set animation bunny happy instead of bunny sad. Okay, so a little bit of vitamin D from the sun makes the bunny happy, although I'm a little bit alarmed with this example. But we'll move on with it. I don't like the sad bunny. I mean, I like the sad bunny, but I don't like that the bunny is sad. I should phrase it that way. I like happy bunnies. I like it when bunnies are happy. Goodness gracious. Okay, circular collider. These coins are supposed to stop when they touch. Let me see where we are in time. 20 minutes, not bad. These coins are supposed to stop when they touch, but the colliders are the wrong shape. Change the collider of each coin to a circle. Do this. Use set collider to change the collider of each sprite to a circle. Okay. So I want them to do that. Right now, they're squares. So, they slightly, ever so slightly overlap. So there's velocity. Debug is true for coin 1. I don't like where you are sitting. I'm going to move you. And I don't like where you're sitting either. Okay. Change the coin 1 collider here. So let's go into the sprites drawer. Here's set collider. And set collider for coin 2. So for this first one, coin 1, change that to a circle. Coin 2, changing that to a circle. Reset run. Now my colliders, or hitboxes, either way you want to phrase that, both of those terms get used. I typically call them hitboxes. If you want to call it a collider because it says collider, that's cool. But just know that when I say collider or I say hitbox, I'm talking about the same thing. Collider and a hitbox are the same thing. All right, so changing them to circles makes sense because these objects or these sprites themselves are circles. Okay, finish that one. Continue. We've now done the practice bubbles. Let's finish. We're on bubble 8. Okay, rainbow horse. Rainbow horse. I like that. That's a good band name, Rainbow Horse. And look at this rainbow just shone. Okay. Because that's what rainbows do in real life, as we all know. That's science. When the rainbow touches the horse, it should turn into a unicorn. Naturally, because that's also how science works. Do this. Add code that changes the horse sprite's appearance into a unicorn when the rainbow touches it. All right, so we need to go into if statement. And we're going to plop that right here where the comment block says, change the horse to a unicorn when the rainbow touches it. So if sprite is touching target, if rainbow is touching horse, then set animation of the rainbow to, we'll make sure the unicorn's over here. Yes, it is. And look at that amazing looking unicorn. Set it to unicorn. Run. Oh, he's an upside down flying unicorn. Can I change his rotation? I'm doing it. Rotation direction. Where is he? Rainbow sprite rotation direction. Rainbow 180. Let's see. No. 90. That's not working. Why isn't that working? Oh, because of this here. Rainbow direction. False. Nope. True. Oh, why isn't anything changing? Let me just pull this out and see. No. Control Z that. Show text. Let me see here. Inbo.rotation equals semicolon. Okay. 180. Show blocks. Now we've got a rotation block. Reset run. Whoa. Okay, that's not what I intended to do. All right. We will just hang up the phone on that problem. And I'm going to call it good. So finish, continue. All right. Collision challenges. Try out these new blocks and challenges with collisions. Choose from the following activities: collider at an angle, improve collisions for sprites with angle animations, and then B is debug, add points on collision, figure out why this code is adding way more points than we want it to. Okay. So we've just got 2 challenges we're going to do, so let's do A first. Collider at an angle. Angle the collider to fit the rolling pin. So run. All right, so I want to angle the collider. Ooh. All right, so set collider with multiple parameters. Set collider can take more parameters than just the shape. It also takes parameters to specify the X, Y offset, width and height, and angle. Check out the documentation for an example. Do this. Use set collider with 6 parameters to give the rolling pin a collider that fits it well. Hint, hover over the set collider block in the toolbox to see an example of how to do this. Okay. Set collider block. Sprite.set collider type X offset, Y offset, width, radius, height, rotation offset. Goodness. All right. So we've set that to true. Let's do set collider. This one is a challenge. Roller. So I want to set those out here, right? That first one is type. That's either rectangle or circle. The second value is X offset. I will be right back. I'm going to think on this one for a minute. And we're back. Okay, so I'm going to pull this back out and then put it right back in to illustrate what we're working with here. So we got to match the name of the sprite first, roller to roller, so the computer understands what we are changing. So rectangle, right? You can set this to either rectangle or circle. And in our set collider block, if we hover over it, you can see that first thing you've got set collider type, which is that rectangle or circle. Then you've got the X and Y offsets, and then width and radius parameter, height parameter, and rotation offset. I think to accomplish this particular problem, we're going to mess with width, height, and rotation offset. We won't need to mess with X and Y offset, I don't think. And there are, let's see, 1, 2, 3, 4, 5 times I need to click this arrow. 1, 2, 3, 4, 5. So for X and Y, since we're not changing those, 0, 0, And then I'm going to set this to 50. We're just trying some numbers. 180 and 50 again. We're probably going to have to change these. So 50 is my, let's see here. 50 is the width. 180 is the height. And rotation offset is the degrees at which I want it to go flunk, right? Okay, so run that. Ooh, okay. So now we can play with numbers and see what we're getting. So the rotation offset is the first thing I need to change. Let's change that to 40, see where that goes. Reset run. And as long as my roller.debug is set to true, I can see that collision box or hitbox. If I say false on my debug, I can't see that anymore. So I always want to use this code and I want it to be true while I'm working on my program. Now I can leave that in there, but if someone's going to be playing my game, I want to change that to false so that when they run it, they can't see the hitboxes. Only the programmer wants to see the hitbox. So as I'm working on my game and programming it, I want to make sure that I'm getting that right. So it needs to be less than 40. So let's see what 30 looks like. 30 looks good. That looks like the right angle. But now my width is way too much. So let's try 40 for the width. It's better, but not quite. Let's see what 30 looks like. It's a little too skinny. Let's try like 34. Maybe it's still a little too big. 33. Looks good. I like 33. And then these ends, not a whole lot we can do, but it looks like that distance is about right. Let's see 175. That's too small. 177. I think 178 will do it. Yep, 178. So look, going back through this, the parameters, right? Those first two, that's X offset, Y offset, width, height, angle. So the angle is what makes it shape go with the shape or the angle of the shape. The width is this way. The height is this way. So, in the future. So, you're probably going to be using sprites and shapes and objects and things in here that you want to have hit detection set to that are all going to be, might be at different angles, might be at different sizes, shapes, whatever, and you can play with this. And so if I change this to a circle, right? Oh, now it doesn't like any of what I've set. Usage, set collider, offset, X and Y. Okay, so it only likes those numbers if it's a rectangle for some reason. But the rectangle works, thankfully, so we'll keep it at that. Okay, whew. Finish. Continue. We're on B now. Add points on collision. All right, games often give you points when two sprites touch. This program does that, but notice what happens to the score as sprites continue to touch. Your challenge is to get it so that only 1 point is scored. There are multiple ways to do this, but the easiest way is to move one or both sprites to a different location right when the score increases. There are multiple, but the easiest way is to move one or both sprites to a different location. Okay. So do this. Read and run the code to understand how it works. So run it. I'm moving the ghost with my arrow keys. When I touch the, okay. So as I'm touching the coin, those points are just skyrocketing up, right? I like it because I'm scoring lots of points, guys. Lots of points. Okay. and I just leave it there. Relax. Oh, this game is so easy. Oh, I'm so good at this game. I can play this game while I'm sleeping and get the world record. Right. I don't want my game to work that way. I want there to be a challenge to my game. So if ghost is touching coin, here's all my movement. So if key down up, go up. If key down down, go down, so on and so forth. Background being made light blue. The text for my points, and my points variable is up here. So variable points gets 0 up here. Drawing the points on the screen, text points plus points, right? And 2525 is the X and Y properties telling it where I want it to say points and where I want those points to be. So you can see inside these quotation marks, points with a capital P, colon, that's what shows up there, points, colon, and then the score right out from it, right? Which is set up here, plus points. Okay, so if ghost is touching coin, then points gets points plus 1. And if ghost touches coin, then I want the location of the coin sprite to change. So and I want coin X and coin Y to change to a random number and a random number between, let's say, 375 and 375, and 375 and 375. The reason why I didn't make these 400 is because I want that coin to be completely on the screen. So now when I run it and I touch the coin, I get 1 point and my coin changes location. Oh, wait. I see. 0. That was my bad. 0. So now 0 between... Oh, wait. I don't want it to be 0. I want it to be 25. Keeping it on the screen is my important thing. Okay. Now it should work. Touch it, and now it's going to random locations. So every time I touch the coin, coin changes its X and Y location. So again, reading that out, if ghost is touching coin, points gets points plus 1, adding to this variable that was set to 0 at the beginning of the game. When I touch the coin, if ghost is touching coin, coin.x gets a random number, and coin.y gets a random number, right? So it's X location and Y location changes. Very simple game, but a fun kind of game. A game that actually has some challenge where the game before had no challenge. Now, another thing you could do with this game is set a timer on it. So you could say, like, see how many points you can get in 60 seconds, right? And then write down your high score. Finish. Continue. Cool. All right, that's that. If you want to go into free play, that's up to you. All I require is that you do the challenges that I complete. That's it. Finish. And next lesson is a mini project we'll be working on making a side-scroller game. So that's it for this one. I hope you had a good time. I know I did.